right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it for today. This video is going to be really similar to the one right before it in the series, which was on two-step equations. They have another one here on multi-step equations, and so just so you have a little bit of context here, this is one video and part of a series on all of the Algebra 1 worksheets that are available out there through like Kuta software, that sort of thing. Okay, so the purpose of this is so that you can learn how to do the thing that your teacher assigned you for homework or for classwork or for both, so that you can understand, do well, and then get a good grade on this, get a good grade on maybe the upcoming quiz or test. So let's go ahead and jump in. And like I said before, we've done something like this before with two-step equations. So I'm going to post that video at the end of this video as one of the links so you can check that out. I'm not going to focus as much on the process because the process is exactly the same as that video. So I'll put that in the chat or in the link at the end. But let's go ahead and look at the process just a little bit for some context here. So if you spell PEMDAS backwards, spell SADMEP. And you're probably like, oh, what do we need? Why do we need to spell PEMDAS backwards? Or maybe you're asking, what is PEMDAS? PEMDAS is what's called the order of operations, but more specifically, it's the order of operations for simplifying stuff. As in, like, in an equation, if you do something on one side of the equation, not on both sides, that's simplifying. If you do something on both sides of the equation, that's solving. So that's SADMEP. So with SADMEP, that's our order of operations for solving. Order of operations for solving. SADMEP. Okay. And then so on top of that, here's the steps, right? So here's how we're going to solve every single one of these. Step 1, you see if you can simplify anything. Step 1, simplify, right? So that's PEMDAS. Step 2, you identify the operations. Identify the operations. And I kind of said that a little fancy, but basically what I mean here is just look at every math thing that's going on. Look at every math thing that's going on. What's going on? What sort of math is happening? Identify all of the things that are happening in the math, and then you order them, right? So based on SADMEP. So then you solve, right, based on SADMEP. So you order them, right? And then you do the opposite. Do the opposite operation, right? So the opposite operation of plus is minus. The opposite operation of times is divide, so on and so on. Do the opposite operation until done. All right, so these are like your little abridged notes right here. Okay, simplify if you can. Identify the operations, solve based on SADMEP, do the opposite operation until done. So let's go ahead and jump into number 1 here. Negative 4x minus 6x. Those are like terms. Those are like terms because they have the same x and they have the same amount of x's, meaning like it's not negative 4x squared minus 6x. Those would not be like terms. They both have x's, but if one of them's squared, one of them's not, or they just have different powers, then they're not like terms. These are like terms, which means I can put them together, which is a PEMDAS thing. Negative 10x. That's PEMDAS because I didn't affect the other side. The other side is negative 20, and it was unaffected. If you can do a step and it doesn't affect one side of the equation, that, my friend, is PEMDAS. So we just did PEMDAS. Right, so step 1. Step 2, identify the operations. Well, now there's only one operation. Negative 10 times x. That's one operation. There's one math thing happening here as far as on one side. Now, after you're done simplifying, you should only have like one or a couple things on one side. And then you want to focus on your x or whatever your variable is. So in this case, we have 1x, it's on the right, and there's only one thing stopping us from having x by itself, and that's that it's, multiplied by -10. So identify the operations. There's only one. So then I don't really need to worry about step 3. Step 3 is just ordering your operations, making sure you go in order. Well, there's only one, so there's only one way to do one thing. So we're going to do the opposite. What's the opposite of multiplying by -10? Well, dividing by -10, right? Not dividing by +10. That wouldn't be the opposite. You'd be switching too many things around, right? It would be like saying the opposite of cold water is hot food. Like, what? No, the opposite of cold water is hot water, right? So -10 times x, the opposite of times is divide. So I'm going to divide by -10 on both sides. Negative divided by a negative is a positive. So this is 20 divided by 10 is 2, and it's +2. And now I'm done. Step 1 done. Now, if you felt like that was a little slow, that's fine. I'm going to actually speed up a little bit as I go, which I do in pretty much all my videos. So you're welcome to just hang out with me as I start to go a little faster. Or if there's a particular number that you're stuck on, you can just skip forward to that. Or if you just feel like I'm going too slow already and you just want to speed things up, but you are waiting for me to do number 2, you're welcome to double the speed or whatever. Whatever works for you. I don't really care what you do to the video as long as it helps you. Okay, I don't care about watch time or anything like that. So let's go ahead and jump into number 2 here. 1 minus 2n plus 5. 1 minus 2n plus 5. Okay, so step 1, let's simplify. There are some like terms here. 1 and plus 5. If I ignore the minus 2n, remember the sign belongs to the number that is to its right. So that negative sign belongs to the 2n, not to the 5. So it's actually 1 plus 5. 1 plus 5 is 6. Okay. And I could have put that on the left or on the right-hand side. I could have said 6 minus 2n, or I could have said -2n plus 6. 6 is positive. The 2n has a minus sign in front of it, either a minus sign or a negative sign. Okay. Minus signs and negative signs are pretty much exactly the same thing. Now there's nothing else to do as far as simplifying goes. We didn't affect the left-hand side, so we were just simplifying. Identify the operations. Okay, there's two things. There's 6, which is a positive number, which is actually being added to -2n. That's like a better way to think about it. It's actually being added to -2n. It's 6 minus 2n, yeah, but the 6 is positive. You do the opposite operation to the number. So that's happening there. And then -2n. Well, same as number 1, -2n means that the -2 is being multiplied by the n. So according to our order of operations for solving SADMEP, we do subtraction or addition on both sides of the equation first, and then multiplication or division. So we're going to get rid of the 6 first. The opposite of 6 is -6. Again, even though it's 6 minus 2n, I'm not going to add 6. You don't do the opposite of the sign in between. That's not a thing. Okay? The sign in between just lets you know that you have to either add or subtract. I know that's kind of tricky, but if it helps, what you can do is you can order it so that the n comes first and then the number. So you could have said 6 equals -2n plus 6. You could have done it that way. Okay. And then you can easily see here, oh, okay, well, then I obviously need to subtract by 6 on both sides, right? So either way, if it helps, just reorder the letter and the number so that the number is after the letter. And then you could just do the opposite of the sign that's in between them. Okay, so if that's an issue for you, if that throws you off, you can always do that. Okay, it's actually going to cancel on both sides, but careful when you cancel, because when you cancel, it doesn't make the equation go away. Okay, sort of like matter cannot be created nor destroyed. Well, we can create math problems, but we can't destroy an equation. Okay, and then once we get here, it's pretty much the same thing. I ran out of space right here, so I'm going to scratch that out and just continue solving right here. Okay, so I subtracted by 6 on both sides. I have 0 equals -2n. And then the second operation was to divide by -2. 0 divided by any non-zero number is 0. And I've said this in the last video, I'm pretty sure, but I said it a little bit differently in this video. So if you've seen the last video and then you saw this video, I said it a little bit differently because in the last video I said 0 divided by anything is 0, which is true for every number except for 0, actually. 0 divided by 0 is just not a number. It's really weird. It's like the universe breaks or something. So, number 3. On to number 3. I got a couple things going on here. We've actually got x's on both sides and numbers on both sides, so there's nothing to simplify, technically speaking, because there's no like terms on each side. 8x minus 2, I can't combine that. Negative 9 plus 7x, I can't combine that either. So there's no simplifying. Step 2 was to identify all the operations. Well, there's a couple different operations happening here. You're not just solving for one x, though, anymore. There's two x's. So our game plan changes just a little bit because normally you just try to get rid of, you just find out where the variable is, and then you just try to get rid of all the numbers around it. Well, in this case, there's two of them. So we have to combine those first. We have to get those x's together so that there's only one x to solve for. And we actually do that with opposite operations as well. So we could subtract 8x on both sides, or we could subtract 7x on both sides. You can do either one, and it doesn't really matter that much which one you do. So I'm going to actually subtract 7x because I like to keep my x positive. And if I were to do it the other way around, I would end up with a negative x, because then it would be 7x minus 8x, so I'd get negative 1x. But in this case, I get x, or 1x. 8 minus 7 is 1, so it's 1x, but when it's 1x, you don't need to write the 1 in front. So x minus 2 equals negative 9. And then I actually need to do some more SADMEP, the first two steps of SADMEP, that is. So I just did S in SADMEP. I might need to do another S in SADMEP, or I might need to do another A in SADMEP. Like I could do two A's or two S's. Just like in PEMDAS, you might have to multiply several things before you move on to divide, and then add, and then subtract in PEMDAS. So here I don't, but other times I will have to. So here I'm going to add. The opposite of minus 2 is plus 2. I'm going to add 2 on both sides. And then actually I'm done, because negative 9 plus 2 is negative 7. And now I've got x solved for. That's why I like to keep my x positive, or whatever the variable is. Because sometimes you end up with just that variable as opposed to like a negative 1 of that variable, and then that would give you an extra step. So sometimes it saves me one step. So like I said, not super significant, but still helpful. So number 4, same thing as number 3. Not going to spend too much time talking about this because I already did. I'm going to add 6a to both sides. And I also promised earlier that I was going to start to speed up a little bit as I go. Negative 5a plus 6a. Wait, why did I do plus 6a? I think I was thinking of like adding them or something. Sometimes when I'm trying to talk and write at the same time, it just doesn't work out. Lo siento. Plus 5a. There we go, because I'm going to get 6a. That's what I was thinking. So I was like working ahead of myself. A plus 5a is the same thing as 1a plus 5a, which is 6a. 6a plus 5 equals 5. And then I want to subtract 5 on both sides. I'm running out of space here, so I'm not going to show that in-between step. But if I subtract 5 on both sides, it's 6a equals 0, which means a equals 0. All right, I skipped a lot of steps there because I kind of ran out of space. But that's the thing, is this worksheet, it's not spaced out really well. So I'm having to squeeze in some of my work here. Maybe I'll just try to write a little smaller. But let's go ahead and look at the next one. So this one, there's a bunch of 4s everywhere, which might seem a little weird. And it kind of is, actually, because this is one of those unique equations where there's actually no answer. Because when is negative 4 ever equal to 0? Right? Like wait. Wait, what? Negative 4 is not equal to 0? So what does that mean? It means there's no solution. All right, so you can just do this. This means no solution. Okay. And if your teacher doesn't like you to just put a 0 with a slash through it or something, then it's fine. Put whatever she or he wants you to put. But I like to just do that because it's easy. Doesn't require a lot of words. 0 with a slash through it means no solution. Because what happens is no matter what you were to plug in for m, because remember m is like a variable, right? So like if m is 2, well then you would still be subtracting 8 on both sides because 4 times 2 is 8. So it would still cancel and you'd still end up with negative 4 equals 0. No matter what m is, it would be the same on both sides. It would be, whatever m is, and then you times it by 4, and then you get the same number on both sides, and then you end up canceling it, and then you end up with negative 4 equals 0 every time, no matter what m is. So it always cancels, so you always get negative 4 equals 0, which is not a thing. Like 2 plus 2 doesn't equal fish, right? Like, I'm sorry. So whenever that happens, the answer is that there isn't an answer. All right, moving on. So 5p plus 3p is 8p minus 8. P minus 1. I do slow down a little bit if it is something new. So if you were just like, wait, hold on, he's slowing down again. I slow down if it's something new, right? So number 5 was definitely a new thing. I feel like we had to talk about that a little bit. But yeah, so I just added them, and then there's no more like PEMDAS stuff to do here, right? So then we go into solving. Well, I can do 2 things at once here, actually. If you're done with that, if I subtract 1p on both sides, then that would cancel there. And then I can add 8 on both sides at the same time. This is like some pro status stuff here. So then what happens is negative 1 plus 8 is 7. 8p minus 1p is 7p. All right, so I'm going to rewrite this over here. And then I divide both sides by 7. P equals 1. Okay, it cancels on the right, and I didn't cancel it on the left because when you divide 7 by 7, it always equals 1. It's not like it equaled 2 different things in there. But 1p is the same thing as p. You don't need to write the 1 in front, which is why I slashed it. Okay, on to the next one. And this is only a 1-pager, by the way. So if it seems like I'm going a little slower compared to other ones, I'm actually almost done because like there's 20 questions. And we're, almost halfway there already. So I think the questions on this worksheet were just like spaced together a little more or something. Let's go ahead and dive into this. All right, remember I like to subtract the smaller number, so that goes away there. Minus 4 and minus 4. Okay, and I get 3p equals negative 14 minus 4. So that's actually adding 2 negatives, and I would get negative 18. Then I divide by 3. So p equals negative 18 divided by 3. Negative divided by a positive is a negative, and then 18 divided by 3 is 6. There we go. All right, here's another one of those things. Look at that. This is exactly like the one we just did before. The p cancels, and I get negative 4 equals negative 9. And I can stop there. Boom, no solution. That's it. If the variable cancels on both sides and you only have numbers left, then there's actually 2 options. All right, so far there's only been one of the 2 options. If both of the letters cancel and you just have the numbers, then the equation is either always true or never true. So in this case, negative 4 equals negative 9? No, it doesn't. But what if it said p minus 4 equals p minus 4? Well, yeah, that's always going to be true. P minus 4 is p minus 4. What do you mean p minus 4 equals p minus 4? If it said that, that would always be true. So then the answer would be all real solutions. And I like to put R's for that. Or ARN for all real numbers. All real solutions, all real numbers, that sort of thing. So you would put one of those things as your answer. And we might come across that actually, because I've seen 2 of these now. We've seen 2 of these now. Okay, so here, number 9. In the last video, it was faster to just look at it as a PEMDAS problem, or sorry, a SADMEP problem than a PEMDAS problem, if you have the option. Here, I can look at it as a SADMEP problem. SADMEP. and then inside of a parentheses is another SADMEP. And that pattern would continue infinitely, but, hopefully your teacher doesn't have that pattern continuing infinitely, because then that would be a really long problem. So what I mean by this is this negative would be, I would be dividing it on both sides. I could also multiply it, but I'm going to divide it. I could divide that on both sides, and then I could subtract 4 on both sides. But that minus 4 would be once I break open that parentheses. That plus 4, x plus 4 in the parentheses is, well, in a parentheses. So it would be the P in SADMEP, which means I would save that, everything inside the parentheses, until after I break open that parentheses. Right? Like a treasure chest in Legend of Zelda. Right? Once I open that treasure chest, then I can deal with what's inside. So that's how I'm going to view this. You could distribute. That would be PEMDAS, because the -8 would be unaffected. You could distribute, but if you want to see both of those methods, again, check out the video. It's at the end of this video. It's on two-step equations, and that will show you how to do that, how to do both ways. I'm just going to do it one way on this one, okay? So -1, divide it on both sides, right? So that's the D in SADMEP. So then x plus 4 equals 8. -8 divided by -1. A negative divided by a negative is a positive. -8 divided by -1. So 8 divided by 1 is 8. Okay, then I subtract 4 on both sides. Just like that. So x equals 4. Kind of had to squeeze that in there a little bit. Okay, and that's it for that one. Okay, so we have the same thing on number 10 here. So I'm going to do the exact same thing. Divide by 4, divide by 4. Boom. This is going to be -3. -6x minus 3. And now I do SADMEP all over again, now that I've broken open that parentheses. So I add 3 on both sides. And then I'm going to get 0 equals -6x. Divide by -6. X equals 0. There we go. All right, let's change color. And now we are officially halfway through. And this second half is going to be a little bit of a faster half, because at this point I don't think anything is going to come up that's really going to be that different from what we've already done. So this is going to be the faster half. Okay, so I'm just going to kind of go through. If I missed something, if I got the answer wrong, if I'm going too fast, if I'm not explaining something right, just let me know in the comments, and I will fix whatever mistake I made just for you. P equals -6. That's it for that one. That's all we do. On to the next one. This one's really similar to that other one that had the negative in front. I can just break open that negative. Okay, and then I do SADMEP. Subtract 7. All right, I'm subtracting because the 7 is positive. -16. X equals 4. All right. Next one. And I kind of drew over it a little bit, but that says -18 minus 6k equals 6 times 1 plus 3k. Now, in the past, we've divided by the number in front of the parentheses. We can actually do that here, because 18 and 6 both divide by 6. But you have to be really careful here, because it's a little more complicated. So we could distribute, and we could totally do that. I'm not going to distribute unless I really need to, and I don't really need to here. So I'm going to show you this method. There's not really enough space on this worksheet to show you multiple different ways to solve something. So if I divide this by 6, then each thing gets divided by 6. All right, so then that happens. Let's add k to both sides. All right, so plus k, and then -1 on both sides. So we end up with -3 minus 1 is -4. 3k plus k is 4k. And then divide by 4. K equals -1. Cool. Now, number 14 is different from number 13, because in number 13 I could divide both sides by the number in front of the parentheses, but in this one I can't. Because here's a -2. If I divide both sides by -2, it goes into 34. I can divide 34 by 2. and negative 2. But I can't really divide 5 by 2. I mean, you can because you get a fraction, and that is still a number. Fractions are numbers too. But nobody likes fractions, including me. So if I can avoid fractions, I'm going to avoid fractions. So instead of dividing both sides by 2, I'm going to have to distribute here. Negative 2 plus 14n. Negative times a negative is a positive. Then I can go ahead and solve from there. Okay, so minus 14 in on both sides. Oh, put that in the wrong spot. Oh, wait, hold on. I was thinking the 34 had the in it for some reason. It did not, so let me fix that. I don't want to subtract it. You could, right? I could have still subtracted 14 in on both sides, but I don't want to. I want to keep my ins positive. Okay, so I did that, so that means I would add 2 here. Add 2, add 2. So that would be 36 equals 9 in. So 36 equals 9 in. Divide by 9. N equals 4. There we go. All right, cool. We're almost done. We got 6 more. Let's do this. As we get to the end here, what you can do is, once I start solving it, you're welcome to start trying to solve it as well. See if you get the answer faster than me. And let me know if you do in the comments. I'll give you like a shout out in the next video if you do. Let's look here. It looks like all of these numbers divide by 2. So I'm going to divide everything by 2 on both sides. So it would be 4x minus 3, because the 2's would cancel right there. But then the 8 over 2 is minus 4. Again, be really careful doing it this way. This is like pro status stuff. And I would, excuse me, I have the hiccups. I would solve it several different ways, but like I was saying earlier, just the way this particular worksheet is formatted, I can hardly fit one solution in here, much less 2. So just the formatting is to blame here. 4x minus 3 minus 4. Minus 3 minus 4? What? That's minus 7. Equals 2 plus x, and then I would subtract x on both sides. So I'd have x right here. 3x minus 7 equals 2. 3x equals 9. X equals 3, and there we go. All right, next one. So here we're going to do negative 8 times 6. 6 times 8 is 48, so that's negative 48 minus 40n equals 3n minus 5. And we're going to do that thing where we add or subtract the n's, add or subtract the numbers as well. So we're going to add 5, add 5. And notice whenever I do this, if the n ends up on the left, then I get rid of the number next to it. If the n ends up on the right, I still end up getting rid of the number next to it. So that's been my strategy all along. If you mess it up, it's fine. You would just end up with like the equation equaling 0. And then you could just continue from there. It just will take you a couple extra steps maybe to solve. But there's really no wrong way to solve an equation as long as you do whatever you're doing equally on both sides of the equal sign. You could choose a really poor way to get the answer, but as long as you're doing the same thing on both sides of the equation equally, you're not doing anything wrong. It just might take you a little longer to get to the answer than whatever the fastest method is, right? So that's negative 43. 43n equals negative 43. And that worked out pretty nicely again. Look at that. 43. 43 is a pretty big number, and I'm pretty sure it's prime, which means it doesn't divide by anything but 1 in itself. So that kind of lucked out there that we were able to do that. All right. Whew, there's a lot of stuff going on here. We could divide by like -1, but we couldn't divide by -6 because this whole parentheses thing right here doesn't have a 6 in it, so that wouldn't really work out. So we'll have to distribute. I mean, we could divide everything by a negative, and that would break open the parentheses right here. But I might as well just go ahead and distribute both. So distribute. That's -1 minus 7x. Distribute this. That's going to be plus 42 plus 6x. and then just combine like terms. So that's going to be negative x when I combine the negative 7x and the 6x, and then this is going to be 41. It's 36. Subtract the 41. All right, so that's going to be negative 5. So x is 5. All right. So we ended up subtracting 41 on both sides. All right, this one, same thing, because 43, again, I'm pretty sure it's prime. I really can't think of anything it might divide by. So definitely not going to try to divide. We're going to distribute this bad boy here. So negative 12x minus 9. Nope, not equals. Let me go back. Got a little ahead of myself there. Negative 12x minus 9 plus 24x plus 4 equals 43. All right, then we're going to combine like terms. Negative 12x plus 24x, that's 12x. Minus 5 equals 43. We want to add 5 to both sides. So that's 47. Oh, not 47, 48. 48, and then I have 12x equals 48. So I divide both sides by 12. X equals 4. And then I'm done. Look at that. And then next I have this one. So it looks like 4 divides into 24, but not into 22. So again, I'm kind of stuck. Got to go ahead and distribute that 4. Plus 24a equals 24a minus 22. All right, and then, oh, hey, look. There's that thing again where the a things cancel. You see that? It happened again. Man, that's the third time this has happened. And every time it's happened so far, we've ended up with no solution because negative 22 does not equal negative 4. Man, kind of a bummer. I'm kind of hoping that one of these will cancel and I'll end up with all real numbers. If it doesn't, I'll show you that and what that looks like. Kind of talked about it before, but I'll show you a quick example at the end of this video as a little bonus. So negative 5 plus 25x minus 40x minus 10 equals negative 4x minus 8x. Whew. Quite a lot going on here. Oh, hey, we can combine these things over here. This is negative 12x. And we can combine some stuff over here, too. So 25x minus 40x, I'd be subtracting. 40 minus 25 is 15. So it would be negative 15x. Negative 5, negative 10, negative 15. Look at that, bunch of 15s going on here. Okay, so we would add 15 to both sides. You get 3x. And then divide by 3, you get negative 5. And there we go. All right, so that's it for that. Let me go ahead and switch back to another color. Do like a nice purple color here. And you can see the answers right here. So if I missed anything, let me know if I missed a solution. All right, see, so it says no solution, number 5 and number 8 and number 19. But it would say all real solutions if it said something like this. Let's say I have 2x plus 1 minus 2 equals 2x. All right, let's say I have something like this. Okay, well, let's solve this thing. Right, so 2x plus 2 minus 2 equals 2x, okay? That would cancel, right? So then 2x equals 2x. And then there's really no way to solve, right? Because, if I subtract 2x on both sides, I would just get 0 equals 0. Well, that's always true. 0 is always equal to 0. It's like, no duh. Something's always going to be equal to itself, right? So then this would be all real solutions. All real either solutions or numbers. Those are the ones that I see the most often. If you see a different one, let me know in the comments. Like if you guys say it a different way, like when the answer is all the answers, or like maybe you guys say infinity or something. But I usually abbreviate to all real numbers or all real solutions. All real numbers or all real solutions, and I just abbreviate. And that's usually what I've done, both as a teacher and as a student and as a tutor now. So speaking of, that kind of concludes this video. If you need tutoring, let me know. You can reach out to me. I have my email in the comments below. I have that in every video so that you can reach out to me for tutoring if you would like. That first lesson is always free. And then after that, we can figure out like if we want to move forward or not, if it's a good fit, and that sort of thing. Also, if you would like to figure out what kind of math you might be the best at, and then what kind of careers that might translate to, if that's something that interests you, I just made a personality quiz. It's awesome and it's free, and you just go to the website myersmathematics.com/quiz. All right, so myersmathematics.com/quiz. I'll put that in the description below as well. And you can figure out what kind of math personality you have, what kind of math you might be best at, and what kind of careers that could translate to. So if that's something that interests you, go to myersmathematics.com/quiz, as well as my 5 mistakes everyone makes and how to avoid them PDF guide that I have that's also free, and I'll have both of those in the description below. All right, so with that, have an awesome, blessed day, and I will see you again in another episode real soon.